The surface of Mars may appear barren and lifeless, but it seems the red planet is keeping quite a few secrets hidden from prying human eyes. A European Space Agency, ESA, probe has found enough water to cover Mars in an ocean between 4.9 and 8.9 feet, 1.5 and 2.7 meters, deep, buried in the form of dusty ice beneath the planet's equator. The finding was made by ESA's Mars Express mission, a veteran spacecraft that has been engaged in science operations around Mars for 20 years now. While it's not the first time that evidence for ice has been found near the red planet's equator, this new discovery is by far the largest amount of water ice detected there so far and appears to match previous discoveries of frozen water on Mars. Excitingly, the radar signals match what we expect to see from layered ice and are similar to the signals we see from Mars polar caps, which we know to be very ice-rich, said lead researcher Thomas Waters of the Smithsonian Institution in the United States in an ESA statement. The deposits are thick, extended 3.7 kilometers, 2.3 miles underground, and topped by a crust of hardened ash and dry dust hundreds of meters thick. The ice is not a pure block but is heavily contaminated by dust. While its presence near the equator is a location more easily accessible to future crewed missions, being buried so deep means that accessing the water ice would be difficult. Some 15 years ago, Mars Express detected deposits beneath a geological formation called the Medusae Fossae Formation, MFF, but scientists were not sure what those deposits consisted of. Mars' geography is split between northern highlands and southern lowlands, and the huge 5,000 km long MMF is situated near the boundary between the two. It is suspected that the MMF itself formed within the past 3 billion years from lava flows and was covered in volcanic ash during an era long ago when Mars was volcanically active. Today, the MMF is covered in heaps of dust towering several kilometers high. It's actually the most plentiful source of dust on the entire planet, fuel for the giant dust storms that can engulf Mars on a seasonal basis. Were the deposits just dust, perhaps filling a deep valley? New observations by Marcies, which is a subsurface radar on board Mars Express, now have the answer, and it's not dust. Given how deep it is, if the MFF was simply a giant pile of dust, we'd expect it to become compacted under its own weight, said Andrea Sacchetti of the National Institute for Astrophysics in Italy in a press statement. This would create something far denser than what we actually see with Marcies. Instead, the deposits are low in density and fairly transparent to Marcies' radar, which is exactly how one would expect water ice to appear in the data. More pertinent is the question of how the water ice ended up buried at the equator. Subsurface ice has been found in plentiful quantities on Mars before. NASA's Phoenix mission dug up ice just beneath the dusty surface at the lander's polar landing site in 2008. Meanwhile, early in its mission, Mars Express detected abundant water ice extending down into the mid-latitudes, and NASA's Mars Odyssey even found clues to the presence of water in the MMF in 2009. More recently, ESA's Trace Gas Orbiter detected hydrogen from water ice just beneath the surface of Candor Chaos, which is a segment of the immense rip in the surface of Mars that we call Valles Marineris. Additionally, the remains of ancient glaciers, called relict glaciers, have been spotted in eastern Noctis Labyrinthus, which is just 7.3 degrees south of the equator. The presence of subsurface water ice at low and equatorial latitudes hints at how Mars' climate was very different in the distant past. This latest analysis challenges our understanding of the MFF and raises as many questions as answers, said Colin Wilson, who is an ESA project scientist for Mars Express and the Trace Gas Orbiter, in the statement. How long did these ice deposits form, and what was Mars like at the time? The ice's existence could be the result of Mars' wandering axis. Across the red planet's history, the axial tilt of the planet's poles is understood to have varied quite chaotically. Currently, Mars' poles are tilted to the ecliptic by 25 degrees compared to Earth, which has a tilt of 23 degrees, but in the past this could have ranged from as shallow an angle as 10 degrees to as extreme an angle as 60 degrees. During the periods of high obliquity, when the poles are pointing closer to the Sun than the equator, water ice could form in large quantities on the surface at the equator. That ice could then be buried by ash and dust falls, to remain covered to this day. The changing obliquity could also explain 400,000-year-old features discovered on Mars by the Chinese Zhurong rover, as well as the existence of gullies formed by liquid water where no such water should have existed.